All right, last piece on fractions. So now we need to divide fractions. We add, subtract, we multiply. Now we need to divide. So the big thing that you need to know for dividing fractions is what a reciprocal is. A reciprocal is taking a number and putting a 1 on top. Now the shortcut to that is just taking a fraction and flipping it. So if we look at these first 1, 2, 3 examples that I have up here, we're going to go ahead and just find the reciprocal of each of them. No dividing. So in order to do that, all I'm going to do is I'm going to use that shortcut, and I'm just going to flip them around. Flip to recip is kind of what you can use to help you remember what it means. So 2 over 3, the reciprocal is going to be 3 over 2. 1 and 4/15. I cannot find the reciprocal of a mixed number. I'm going to say that again because it's really important. I cannot find the reciprocal of a mixed number. It needs to be an improper fraction first. So 15 times 1 is 15, plus 4 is 19/15. And I'm kind of out of room, but when finding the reciprocal of that, my reciprocal is now going to be the flip of 19/15. I'm going to put a little arrow. My reciprocal is 15 over 19. So there's my reciprocal. There was my reciprocal number 1. On example 3, I have 5, which is the same thing as 5 over 1. Therefore, flipping that, I get a reciprocal of 1/5. Now that I understand what a reciprocal is, let's go ahead and look at the directions for dividing. Once again, just like all the other ones, I'm going to start by changing all my mixed numbers to improper fractions. This is the important step, this one right here, step number 2. I'm going to rewrite the first fraction, the first being the one on the left. I'm going to change the division sign to multiply, and then I'm going to flip the second fraction. From there, I now have a multiplication problem, so I just follow my steps for multiplying. Again, I have to reduce only if that butterfly method or that Band-Aid method, only if I didn't do that perfectly. So let's go ahead and look at some examples. On example number 1, I have 2 1/3 divided by 14. First thing I'm going to do is change my mixed numbers to improper fractions. 3 times 2 is 6, plus 1 is 7 over 3, divided by, notice I'm not going to try to do steps 1 and 2 together. I'm just going to do them as their own individual steps. I'm going to say 14 is the same thing as 14 over 1. And now step 2, the important one, I'm going to rewrite my first fraction, change divide to multiply, and my second fraction gets flipped. Now that it's a multiplication problem, I'll use all my multiplying steps. I see 7 and 14 can both be divided by 7, giving me 1 and 2. I see that 1 and 3 both can't be divided by anything, so I can't reduce there, but 1 times 1 is 1. 3 times 2 is 6 when I multiply straight across, and I can't reduce that, so there's my final answer. 2 additional problems, both of them story problems. Here on example 2, we have Jessie's going to spend a third of her free time studying this weekend. She has 5 classes she needs to study for. She's going to split her time evenly, so she's going to divide her time evenly between all 5 of her classes. I want to know what fraction of her time will be spent on each class. So the first thing I see here is she's going to spend a third of her free time. So that to me makes me think multiply 1/3 times her free time. But nowhere in this problem am I given any information on her free time. So instead I look a little bit further and I see she's splitting her 1/3 between 5 classes. So she's dividing that 1/3 up amongst her 5 classes. So she's taking her 1/3 and dividing it by her 5 classes. Well, according to my steps above, I'm going to say that that's 5 over 1. I'm going to rewrite my first fraction, change divide to multiply, and flip the second one. I can try the Band-Aid method, but 1 and 3 and 1 and 5, neither of them have common factors that they can both be reduced by. So I multiply straight across and I get 1/15. So she's going to spend 1/15 of her time on each class. And that's going to be a total of a third of her free time. The second part of this problem says if she has 180 minutes of free time on Saturday and 110 minutes of free time on Sunday, how many minutes will she spend on each subject? So now I'm going to take my answer here and I'm going to say I'm going to do 1/15 of her total number of minutes. Well, 180 plus 110 is 290 minutes total. So she's going to spend on each class 1/15 of, so multiply that 290, or that 290 over 1. So a review of that multiplication process. 290 and 15th are both, and 290 and 15 I see are both divisible by 5. So using that Band-Aid method and reducing by 5, I'm going to get a 3 and a 58. Multiplying straight across, I get 58 over 3, and I've already done the work to convert that into a mixed number. 58 over 3 as a mixed number is 19 and 1/3 minutes. So you split a minute into 3 pieces, you get 20 seconds. So she's basically going to spend 19 minutes and 20 seconds in each class. One last example. The cheerleading squad is making ribbons for their hair. Each ribbon needs 2/5 of a yard of fabric. We have 6 yards of fabric. So we have these 6 yards of fabric, and we're going to start cutting off 2/5 chunks. We want to know how many times can we do that. So how many times can I divide that 6 yards by 2/5? So dividing that up, I'm going to take my 6 yards and divide it by the amount I need for each ribbon, and that's going to become 6 over 1. I'm going to leave that fraction alone, change divide to multiply. Band-Aid methods, 6 and 2 are both divisible by 2, giving me 3 and 1. And straight across, 3 times 1 is 15. Sorry, 3 times 5 is 15, 1 times 1 is 1. So I get 15 ribbons total is how many I'm going to be able to make after splitting that chunk of ribbon up. But notice that it's a story problem, so I have to make sure I answered the question completely. And it says, will there be any fabric left over? So I'm going to say 15 ribbons with no fabric left over. And that will be my final answer. So you've now seen all the different ways to perform operations with fractions: add, subtract, multiply, and divide. Notice again, division is very similar to multiplication, just that first 2 steps that you're going to have to do first. But once again, any questions, bring them into class with you and we can look at those together.